is 6:50 on Thursday, 3 October, local. We have a good camera, we got a good boom, and we have a video sync. AOA display is up for takeoff. Volume is full up. Just deselect Wi-Fi for now. And that's so the system runs out into auto mode. Double check that. Auto manual and auto. Still not showing VPS, runway FL 17.1. We got 15 degrees. 62, that looks about right. Temperature is probably not correct. Let's go with YT of 20 Charlie. So we'll just set that manually. And that's because we are not receiving the Charlie, and we're 2993, which is really not that big a deal. We'll just leave that at 2993. That's set. Elevation 62. Now we have a solution. All right, let's just get a data mark here. Don't have my lined up queue. Interesting.
Lined up.
There we go.
Data mark. Data mark 1.
All right, rolling. All right, on-speed climb over the obstacles, transition LD max.
Off field.
Directed. Frequency change. All right, we have two Wi-Fi networks on board because we have two systems. We're connected up to the ONSPEED system, the ONSPEED network rather. That's our primary AOA and data acquisition system. Takes inputs from the GNSS, INS, and also the air data boom. And there we go. Once we're there, we're going to just navigate to onspeed.local. It'll take us to our gateway, and we're just going to confirm that we're on the cockpit system, and that all looks good. Once we get up to cruise altitude here, we'll talk about some of the different functionality that we have with the system. Let's just take a brief look at the different functionality we have here with the system through Wi-Fi. And before we get started, let me just emphasize that the purpose of this system is to provide accurate AOA information to the pilot. The primary means of doing that is a aural tone. Secondary means is a visual display. We're going to talk about all of that today. The tertiary capability of the system is a flight data recorder. And the ability to control everything using the Wi-Fi interface. So let's just take a look at that interface. I'm on the home page right now. We have 4 different primary menus up here. On the tools page, that's where we keep our log files. And we also manage our SD card, and it's also how we do any sort of an upgrade. Every time the system is powered up, a new log file is created. We can download those post-flight. Also notice we have a soft reboot capability. Most of the in-flight settings are going to occur on the settings menu. We're going to use primarily the sensor configuration and also the AOA calibration wizard if we're calibrating the system. So the system
Position 501 in Bravo, going to departure IDAT, call my maintain 10,000.
The system configuration menu is how we control everything. So let's just take a look at that. As we go through here, we actually have some pilot selectable settings for the AOA system itself. How we smooth the system, how we smooth the pressure inputs, what data source we actually are using operationally. Right now I'm using the sensors, which means we're using the internal sensors in the system. We have some other capabilities that we use outside of the flight regime as well for that. We can support up to 5 different flap calibration curves. And it's really important that you get a good, accurate AOA calibration for each flap setting on the airplane, because the functional AOA or the body angle will change with flap settings. So we have a curve for that. We support multiple different regression techniques, so we can support just a simple linear regression, a polynomial regression, log regression, and also exponential regression. So whatever we get for best curve fit, the system can handle all of that. That actually happens for the most part automatically. We'll talk about that more when we get into the demo of the actual auto calibration system. Because we have all our flight test capabilities integrated for data acquisition purposes, I've got the flight test boom enabled. I've got my airspeed calibration enabled. That is really there so that you can have a calibrated airspeed source in your cockpit. What I actually use it for in the test airplane, though, is marrying up the indicated airspeed with the primary EFIS system and the box itself. So notice I've got an indicated airspeed of 149, 150, and about 150, 151. So things marry up fairly well using that correction technique. That's my correction curve. The next two parts in here, the pressure ports orientation and the box top orientation, that simply is how the box is mounted in the airplane physically, okay? And that has to do with the sensor calibration. So obviously that doesn't ever change once the box is bolted into the airplane. I have my serial EFIS data enabled, okay? And I'm taking primary data today from the GNSS INS system that's coming into the system at 50 hertz, and it's being recorded at 50 hertz. We support multiple EFIS types, and we'll talk about that in a different portion of the brief.
Check in with your beacon code, please.
The next thing I've got set is my calibration data source, okay? And I can either use the internal sensors in the box, or I can use the EFIS. And in this case, the EFIS is the GNSS INS. It's the most accurate gyro I have on board, okay? And we'll talk about that more when we talk about auto calibration. The volume pot simply controls the big volume knob on the instrument panel, which you can't see because it's buried underneath the iPhone here. And there's the ability to test audio.
On speed left speaker. On speed right speaker.
And that just makes sure that our good stereo hookups are there. Okay, we have a pot value for both low volume and high volume. Once that's set, obviously that doesn't ever change. The next functionality is where I want to mute the tones. I prefer to have the tones down to 25 knots indicated airspeed, but again, that is pilot selectable.
Hagland Tower, Hagland approach, test 1 2.
And 3D audio is just the stereo functionality that moves the tone left and right in the sound field with the skid ball. I've got my over G warning enabled, and
Hagland Tower, Hagland approach.
I actually have mine biased. I've got a 6G airplane, but I like my G warning to come on at 4 Gs for test purposes and negative 2 Gs for test purposes. I've got my VNO chime set, and that just is basically my high airspeed warning, and I've got that set to the top of the green arc, or 157 knots. My chime interval is also pilot selectable. I have that set to 3 seconds. I have the SD card logging turned on, and the serial output format is just what I'm actually transmitting up here TTL-wise to my visual display. That's in the ONSPEED format, and that's going through port 3 in an RS-232 format, and that's just driving the M5. So that's the basic systems menu. We'll talk about the AutoCal menu in just a second. Some other functionality I have is with the live view. The live view is just what the system is doing right now. It just displays everything in the cockpit, especially if I don't have the optional visual display. It just defaults to the same donut chevron trend indicator that I have and gives me digital readout. Right now my body angle is about 1.9 degrees. My IMU derived AOA is about 1.5 degrees. And my flight path is about on the horizon. Indicated airspeeds presented. I've got a pressure altitude of 49.99. That checks. I typically set 2992 for flight test work.
147 Bravo, how much further northbound do you plan on working?
Just as far as the lake. So about 2 miles, sir.
Okay, thank you.
All right, we've also got indicated airspeed information, IVVI information, G information, pitch roll information, as well as what data mark I'm on. I've also got a data mark display up here on my M5. So every time I hit the data mark functionality, I get an update on that. Let me just demonstrate that. For that, it's just a long push and hold. Let me get the phone out of the way here briefly so you can see how I'm using the actual button itself. Obviously the 4 is a tight cockpit, but to get the data mark, all I have to do is push and hold.
Data mark.
I get an update here. I also get an update on the live view display. Let's get back and let's look at the other capes that we have on live view. Just remount the phone. I use a quad lock in the cockpit. I find that to work really well up to 6Gs. And now I am in browsing hell. There we go. Live view. And this is the AOA page. I also have an AHRS page. What's nice about the AHRS page is it mirrors the AHRS up here. And notice it gives me a good warm fuzzy. I've got good IMU capability, which is going to be required if I'm using the internal IMU for our AOA calibration. Need to turn here for airspace. I'm working Eglin airspace, so I'm in Eglin Delta. And I'm under positive control from Eglin Tracon right now. All right, so that's the basic live view functionality. We've talked about settings. The next thing I want to talk about a little bit is a auto calibration. So we have a system set up for auto calibration. And we only have to calibrate the system once, obviously, but we're going to demonstrate how that works. This is something we call the calibration wizard, okay? We do need to input some pilot information here, so we're going to put in the aircraft maximum gross weight, which for the mighty RV4 is a whopping 1,500 pounds. We're going to put in our current gross test weight. I just use a simple lookup table for that. I've got 28 gallons on board. I'm at 1,360 pounds based on my standard zero fuel weights. So 1,316 pounds. I know that my L-Ready Max glide speed at maximum gross weight is going to be 80 knots. So I select that number. Everything is adjusted for gross weight. And I'm going to put in a G limit of 6 Gs for our calculations. And then I'm going to hit the continue button. Let's bring up the next page. These are just calibration instructions. We're not going to discuss that in this brief. And then you can see it brings up the actual calibration wizard page, which mimics our decel display up here. What we asked the engineers to do is give us a display of actual deceleration in knots per second. So if we're looking for a 1 knot per second deceleration, we've got this display. Okay, I'm going to put a data mark right now in the video, and the reason I'm going to do that is because I want to actually be able to pull this display up for the calibration. So we're going to get a data mark in 3, 2, 1.
Data mark.
All right, that's actually data mark number 3. Okay, and we'll sync the video up. Now let me just show you how the decel display works. It's a real intuitive design. If I pull the power back and I decelerate, all I have to do is just pull the gauge up to whatever rate of deceleration I want. And then if I find I'm getting a little bit fast, I just pull back on the stick. If I find I get it's just a little slow here intentionally, okay, then I just push the line forward. You can see over on the right-hand side, I've got a Kalman filtered instantaneous VVI. I've got an old-fashioned mechanical VVI down here on the instrument panel. That is super helpful as far as maintaining a specific altitude. So let's just go to a 1 knot deceleration in here. I'm at a stable 1 knot deceleration. You can see I've got a digital readout on the right side of the screen, then I've got my analog readout in the center of the screen. So that's how the deceleration gauge works. The other flight test screen that I have available is historic G data. That's helpful for wind-up turns, things of that nature. A little better than reading a digital G meter. Okay, I'm going to put a data mark in right now so we can pull that up and you can see that. Stand by, data mark 3, 2, 1.
Data mark.
We'll sync that up. We're in log 1. Okay, and if we actually G the airplane up, let's go put our power back in. Put some G on the airplane here. Let's just go to a stable 2G condition. And just notice when I'm in the 2G condition, as far as the wind-up turn goes, it's just real easy to maintain my G's, kind of cross-referencing the historic display and the digital G meter. and that's the sole purpose there. And if we get to some sort of a high G event, let me just put a spike in here. Just go up, stall the airplane. All right, there's a 3G stall, and notice that we get the nice spike in the data. So that screening is helpful for that kind of work as well. And then obviously we baseline at 1G. And we basically go back in time 1 minute on that display. Other displays we have available are what I call the standard energy display. That integrates a standard donut chevron with trend information, fractional lift information. I've got another demonstration video that'll show you that. Okay, I've got G's over on the right side. I've got indicated airspeed on the left side. I've got the current data mark up in the upper left. And then, because my AOA calibration depends on my flap setting, I actually want to know, and I want to get feedback through the system that my flaps are set properly. So I've got a flap indicator in the lower left. Let me just go ahead and deploy flaps. I have manual flaps here in the Mighty Mighty. Okay, so that's a flap 20 condition. We're flaps 20 LVD max right at the moment, or relatively close to LVD max. And if we want to go ahead and deploy flaps 40, there we have it. So that way we have everything up on the display that we want to see. And let's just talk about the basic energy display. This is our basic display. The way you flip between displays on the M5 is you just press the center button. We have the ADI display. We have a basic angle of attack display with no other information. We have our D-cell display we've already talked about. We have our historic G display we've already talked about. And now we're back to just our baseline display. So let's talk about what's on there. We've got the angle of attack fractional lift information in the center. We've got G's over on the right-hand side, indicated airspeed on the left, miles per hour. It's a Vans Air Force thing. We've also got a data mark up in the upper left-hand side, so I'm currently on data mark 5 on this log file, and a flap indicator in the lower left. The reason the flap indicator is in there is because obviously if we're testing angle of attack, we're going to want to know that the system is getting good feedback about the flap position and I'm on the proper calibration curve. So let me just demonstrate that to you. I've got manual flaps, so the flaps move really quickly. Notice that's a flaps 20 condition, and there's a flaps 40 condition. I've just got 3 flap settings in there. I'm in an on-speed condition flaps 40 now, and I get the feedback I need through my energy display. The display is kind of optimized to give you everything you need to fly the airplane visually. So let's say it was in the back seat of a tandem airplane. If I was an instructor, it would just give me all the SA I need. So that was the thinking behind combining all those different indications. Now let's demonstrate an automatic AOA system calibration. Truth in advertising, we're having damping issues with our slip skid ball right at the moment. So that's going to be less than stellar as we accelerate and decelerate today. All right. Auto-calibrate the system. We've already got things set up in our calibration wizard. We're just going to accelerate the airplane on out to a Vmax condition, so I'm just in mil power right now. Once we get the airplane going as fast as it's going to go, we're going to start the calibration run itself. And that just consists of a deceleration into the stall. Now, altitude control isn't critical, nor is specific deceleration rate. Once we get the airplane up here to the top of the green arc, that's fast enough. We're in a flaps 0 condition, that's confirmed. Let's just go ahead and we'll start the procedure. So we hit the record button, slowly pull the power back. We take about 8 seconds to pull the power back, so we've standardized that. Okay. Notice that the airplane fairly rapidly gets below a 1 knot per second deceleration rate. That's kind of normal with a fixed pitch propeller. If I want things to be precisely 1 knot per second, I've got to give up some altitude to do that. And I just follow the display as I do it. And again, I said altitude control isn't critical. What's more critical is just a smooth buildup of angle of attack. I'm using the deceleration display. I could just as easily look out the window. And it takes quite a while for my low drag fixed pitch propeller airplane to actually slow down. We're actually using software in the phone right now. We're not using the onboard software for calibration. Software on the phone is running at 10 hertz. And that's probably going to give us about 600 data points during this run. which is going to be more than sufficient to calibrate the system. Typically we do that with just 4 or 5 trim shots, using old-fashioned flight test techniques. There's non-speed condition. I typically stop trimming. Obviously non-linear stick controlling or stick inputs right now, so I'm just increasing my pitch rate as I slow down. And once the airplane stalls, notice that the system goes back to record and it produces a calibration curve for us, okay? So I'm going to just save the data to the file, okay? I'm not going to save the calibration because I don't need it. Let's talk about the outputs, okay? So the outputs from the auto calibration, I stall at 47.53 knots. I did a polynomial regression. This is just the polynomial regression curve up here. And it does an R-square assessment. So it tells me how good my curve is. Note I've got an R-square value of 0.9987. And then it computes the different body angles associated with my primary conditions. So I've got an LRD max body angle of 7.11 degrees. The on-speed band is going to go from 11.32 to 12.02 degrees. So it's about, I like to tell people it's about 1 degree wide, but it's going to vary anywhere from about 0.6 degrees to 1.0 degrees, depending on the calibration and the airspeed band of the airplane. And that's going to give us that 5-knot range that we're looking for that. Stall warning is going to occur at 16.39. Okay, and maneuvering angle is something we're not using right now, but that is the 1G angle associated with maneuvering speed, and the airplane stalled today at a body angle of 19.53 degrees. Notice I also get a curve printout, and that allows me to assess the quality of my calibration real time just by looking at the graphic. So we'll save a screenshot of this. Unfortunately, our save screenshot mode isn't working right now because Apple makes a lot of changes to iOS. So I'll just save a screenshot the old-fashioned way. And because I can't get everything on one screen, I'm just going to slide the screen down here. Oops. And we'll take a screenshot of the lower portion, if I can actually make my phone work properly. Here we go. There we go. All right. And we've got a good screenshot. That's how the auto calibration system works. We're getting into a nasty sun angle here for videos, so we'll go ahead and terminate at this time. Huge shout out to Eglin Air Force Base Air Traffic Control, especially the pros at the Tracon there. They make all of this test work practical by not only sharing airspace, but covering my 6 o'clock every time I'm up here, single seat. So the feedback I get from the boom in the cockpit is I've got an LED on there, and by monitoring the LED, I know that I've got good data coming in from the boom. The camera also has a hot LED, so when I'm getting camera and boom checks, I'm just checking the LEDs to make sure that my test systems are working. All right, I'm going to leave 20 Charlie in there, 94 now. We're going to adjust that, leave that at 62. This is my landing roll at 810 feet, 1,660 feet over a 50-foot obstacle, 4 flaps, 40 landing data is checked. So I'm on the RV4 centered screen right now for TLAR. And you can see that basically it's own ship. Let me turn off the Wi-Fi here because right now it's talking to the AOA system. Go back, see if we can't get data. Once we get data, it'll restore our satellite view. I'm going to change this to the airfield view. That way, as we're in the traffic pattern, you can see how the system displays. We still have some satellite view left from takeoff in the buffer. And once we get down in the weeds, we'll pick that back up again. I can send Bravo Romeo at a 4.5 for 1.0, initial 3.6 at Ruckle Field inside.
147 Bravo Romeo, roger.
My airfield is in FAR 93 airspace, right between the restricted area and the Class Delta at Eglin. So positive control all the way in. until I get dropped off in the traffic pattern. Okay, what you're seeing on the video right now is my velocity vector and my predicted touchdown point. Now that's based on the glide data for this airplane. You can see that down in the lower left. So my max LRD max airspeed at max gross weight is 80 knots. My glide ratio is 9.6, and that's actual engine out.
Ruckle traffic, Warrior 2 X-ray is departing the pattern to the north, Ruckle.
Just take a look at a normal traffic pattern here.
Logan Field traffic, that's the 80, turn left base for runway 05, Logan Field traffic.
Just come up initial here at pattern altitude, which is going to be 800. And we'll demonstrate just a normal on-speed approach.
For the traffic, RV 7 Bravo is initial runway 36 option, Ruckle.
Unstable high green.
Here. Gas, undercarriage, mixture, propellers, pumps.
Logan Field traffic, that's the 80, turn final for runway 05, Logan Field traffic.
And throat. All right. Landing checks are complete. So as we decelerate, when we get down below VFE, we'll just go ahead and deploy flaps. Sorry about the retina burn, nothing I can do about that this morning. Notice flap indicator shows flap 20. Roll out here on downwind. Go to flaps 40 condition. Taxi up here to the perch. And we'll basically be on speed all the way around base final. There's an on-speed condition. I've got quite a bit of overshooting wind today out of the east, about 22 knots up here at pattern altitude. Wind out of the north at the surface.
Negative turn back.
So anticipate the overshoot, we're off the perch. Now I'm just maintaining an on-speed condition. Okay. And just flying the tone. Notice the difference between the slightly fast, there's a slightly fast condition. There's an on-speed condition. Let's get slow here intentionally. There's a slightly slow condition. So the tone gives me all the feedback I need for my pitch control. And I'm just controlling my glide path with the power. So basically landing Navy style.
Unstable low green.
Pulling that on final. We got the trees at the end here, so I'm just going to put in a big old slip. Mixture's rich. Landing checks are complete. Let's just pop on down here to the TDZ. We'll go around and we'll demonstrate that one more time. So on the go, you can see as I clean up, there's our flaps 20 accelerating. I typically climb at LRD max, approximate VY. That is the bar aligned with the pips. Blue chevron just lit.
Turn back possible.
Maximum rate of climb.
Local traffic, RV 7 Bravo, range is right, closed traffic, the 36 option.
We'll just slow things down here because the RV4 is a quick little airplane with a really good thrust to weight ratio, so I'll just pull the power back. We'll keep things at a slower pace. Again, we've got this big overshooting wind, so we'll crab out here a little bit on downwind. There's pattern altitude, flaps 20, flaps 40, crab to the perch. Landing checks are complete. There's an on-speed condition, and off the perch.
Local traffic, RV 7 Bravo, has a right base gear down option, 36 left, Ruckle.
And nothing wrong with a slightly fast approach. And notice how the airplane accelerates if I let it fall.
Unstable
I get
fast
all
low
that
green.
feedback from the system. Now I'm so fast, I don't even have an AOA tone. Again, let's just slip down here into the hole, and we'll do one more demo. Order traffic, 7 Bravo, me is on the go, right close traffic, 36 for the full stop, Ruckle.
Off field. Turn back possible.
And that's just oral feedback I'm getting from the TLAR system as far as my ability to maneuver back to the runway if we have an issue. We'll fly a little wider pattern this time. Pattern altitude. Power's coming back. Elevity max is close to VFE, so I actually get flap feedback from the tone itself as well. So once I get tone on the airplane, I can go flaps 20 and flaps 40. Manual flaps have to actually slow down a little bit, be able to deploy them effectively. We'll trim the airplane up, we'll finish our landing checks, we'll confirm that's good, and then we'll wait and we will simply roll off the perch. And again, we're just going to maintain an on-speed condition all the way around. Super easy to do this. Focal traffic RV 7 Bravo Romeo is our right base, gear down.
Negative turn back.
6 left, Ruckle. This time I'm being a little more thoughtful with my energy. Don't really want to fly in the tree canyon until it's time to land. So, again, I can adjust my glide path of power based on the feedback I'm getting from the tone. So we'll do that. We'll keep it up high here,
Unstable
right over
low
the top
green.
of the trees. Mixture's rich. Landing checks are complete. And now we'll let it settle down into the hole and do it without any sort of big slip or anything else. And again, I'm getting all the feedback I need from the tone. And you can hear the airplane slowing down as we put her into 3-point attitude. And now it's just a matter of rolling the wheels onto the ground. I can't carry too much energy if I'm on speed on approach. So it's always going to be a matter of just rounding out and touching down. And we'll save that to files. Okay, and that's just saving the data. We'll replace the old file. And that is that. So that the TLAR system has its own data marks, its own file. We've got the separate data mark system for the primary system. And it's got its own file. We're going to go back into the hangar. We're going to talk about how we actually download the data post-flight. Out of the airplane, obviously I'm working on a MacBook here. What we're going to do is just log on to the Wi-Fi network. We power the airplane up either through a battery or we just turn the master switch on and we find our network. It's going to be the ONSPEED network, the same network we used in the airplane. And then we're just going to open up a browser. And we're going to navigate to ONSPEED local just the same way we did in the airplane. Now the first time you log on, it's going to ask for a password. The password is angle of attack, all one word, lowercase. Once you've logged on once, you never have to add a password again. As far as getting the data out, all we're going to do is go to our log files under our tools menu. Find the log file we want to download, which is going to be log 2. And we just start the download process. It's that simple. After we've downloaded the log file, I also typically grab the configuration file because that's got all my system settings in it. Generally don't need that for anything, but I save it with the data file in the same folder because if there's any question about anything, it's easy enough to look into a config file using a text reader just to see how all the switches, or the software switches rather, were set in the system. And I'm downloading via Wi-Fi. You can see it's a 65 megabyte file, and it's going to take me about 12 minutes or so to actually download that file. I'm going to stop the video. We don't have to watch paint dry, and I'm going to post-flight the airplane just a little bit. But I go through that process. with the primary system, and then like I said, I've got two systems installed on my airplane, so I then download the secondary system, and then we put everything together later on in just to a single data file, and I'll send you an example how that works. Thanks.